On the last episode of Parametric Promethean, it was too spicy for LinkedIn, so this time I'm toning down the controversial humor and focusing on just RhinoInside. You may remember from previous episodes how I had lines and closed polycurves, which I was then able to use my custom components to convert to blocks, and then from blocks convert those to Revit elements with my other custom components. So this time I'm going to scale that up, and I've designed for you my attempt at designing one of those typical multi-residential towers. Now, as a disclaimer here, I'm sure all the architects watching could laugh at me and point out all the things I've done wrong, whether some rooms are oversized or undersized, or corridors and fire exits don't meet planning codes, or something else I've forgotten, but hey, I really don't care. It's not my fault I don't have access to an office right now full of precedents that I could look at and some kind of senior architect who could guide me through and tell me what I've done wrong. For the purposes of today, we just want something that looks vaguely like one of those that we can do some solar analytics on. With that disclaimer out of the way, I'll show you around. So here we have a lift core, we have a fire stair, and a corridor between the apartments. These are little one-bedders with a bedroom and a living room. This one's got 2 bedrooms. This one's got 3 bedrooms, 2. On top of that, we also have some walls that I've drawn just as lines. So if I turn off the spatial planning layer and I turn on these are on the balustrade layer, facade, internal walls, thicker internal walls that go between the apartments. Alright, now we come to the first of our grasshopper scripts for today. I'm going to bring those walls in with a dynamic geometry pipeline. Gets it by the layer, so it's a dummy lines balustrade. We know that it's a curtain wall. And if we get the same for interior, we know it's a generic 100, or a facade, it's a generic 200. So each of these then has a different height and a different thickness. Unlock the solver and we instantly have our walls. And you can see those attributes are put in. Now we don't have a Revit name or Revit ID yet because, of course, it hasn't actually been converted over. The other thing I forgot to mention in case you didn't see the previous video is we also put in these points, which are just the centroids of the closed polycurves. And we put those in here so that we know which is the interior face of the walls. You can see I have a separate BREP here, which is the interior face, and the other BREP, which is the main polysurface solid. The interior face knows it's close to that point. Okay, now it's time to create the rooms. Let's select the sublayer objects, which are all those polycurves representing the room boundaries, and we'll set those to multiple curves. Unlock it. Now what it's going to do is it's going to get each one of these and it's going to test it compared to the walls to find that inner curve which represents the true area boundary of the room. And now those rooms are created. Once again we can take a bit of a look. Inner curve. Okay, what's next? Converting it over to Revit. Okay, first we're going to switch a floor on. I just made those earlier. We're going to grab those blocks, select multiple rooms. You've seen this one before if you watch my other videos. This bit's new, this is just standard RhinoInside stuff for loading in some door and window families. Sorry this takes so long, I would have liked to have had a template file with this stuff already in there, but of course I only have Revit Viewer, so I can't actually save anything. Alright, cool, so you can see the rooms have placed at the center of where they were in the Rhino file, and they found the boundary naturally in the same way that they would normally in Revit. Alright, let's place a door and a window, and we'll send them back to Rhino with the other script. Move the window, move the door. Yep, so notice it hasn't fixed the wall itself because we didn't tell it to. Sand it back to Revit. Yep, the location is updated. Now if we move it in Revit and then send it back to Rhino, and for this one we're actually going to pick a new host. Got to put all the rest of the windows and doors in. I'm not going to show you that drafting process because you know how to do that already. So let's just skip straight to sending the whole thing back to Rhino. Okay, so we've got basic walls, which includes the facade ones and the dividers and the internal ones. And then we've also got the floors. Those are feeding through into one of these squid thingies. We've also got windows, curtain walls, which are our balustrades. And we've got the doors, which are coming in by family. They get amalgamated in that squid thingy. And then we're going to click enabled. Now we'll go back to Rhino. Hey, we have windows and doors. They've come through directly from Revit. What do these consist of? They're also a block. We have the frame, it's on the opaque layer, and the glass on the translucent layer. And as for the doors, if we come around and try and find one, I'm going to turn off the spatial planning stuff so you can actually see what you're doing. Cool, okay, so it's cut a hole in those walls. And you see here, yep, this is door. It's a door category. It's got the Revit host linked to it. Okay, so we copy that floor block up. And then we try and send it through to Revit. Oh no, it's moved the floor slab up rather than creating another one. But that's what we expected. If there's more than one instance of that block definition, then we're going to get this sort of problem. And that's why I created the clone block node. So all I got to do is feed in the existing block, and off we go. And then I got to dismiss this annoying error message, but that's just because of the input node, not my one. This does exactly what you'd hope it would do. Basically just takes a block, copies the geometry and attributes, and makes an identical block with a new definition and a new instance. That way they won't get mixed up. Try sending that through to Revit again, and this time it's a completely new element. See? Look, different block name, different element ID. Okay, so let's scale that up to the size of a whole building. As a lazy option for today, I'm just going to array 10 floors of the same thing, rather than think too hard about what could be with our solar planes or whatever. We'll do that another time. Eventually I want to be building algorithms which will turn a massing model into a floor plan. But I focused my effort on building the connection to Revit first, because that's often where the gap is. You know, there's ones already that can kind of do rough floor plans, and they often work in a browser, but they're not really working in a BIM way from the beginning. Alright, well let's grab all of those and we'll sheep them into new blocks. Dismiss the error warning because of the deletion. Gets me every time, this one. Okay, so they're all unique blocks, and at the moment they'll have no Revit ID assigned. Okay, if I select all of those and send that through, it starts to build them, and then it hits an error warning. Now I haven't yet built enough error handling into this to account for everything, so I don't know exactly what the problem is, It's something to do with the way that Revit manages transactions, and that's just one of the really annoying things about working with Revit. However, if we just grab them one type of element at a time, so let's just do the floors first. And then we'll do the walls. And then we'll do the windows. And the doors. And then lastly, the rooms. That all goes through fine. One of the things I really hate about Revit is all these fucking error messages. I'm just trying to place a room and it wants to, no, but I can't find the boundaries. And it's all just because, you know, there's a balustrade and the lines don't quite meet up, so the bounding is getting confused, and we know conceptually as a human user that there's a room there, but Revit is just... The other thing is, do you remember before it worked correctly and then I must have changed something in the code because for some reason the tags on the rooms aren't coming up properly on level 1 and 2, even though they are on the other levels. And it's very strange because it's the exact same process. So if anyone knows why that's happening, I'd love to hear it. I mean, the tags are definitely there. If I just build this quick little RhinoInside thing here to have a look, do I have any tags? Yes, I do have tags. Okay, the first tag, yep, it's definitely level 1. It's a mystery. Anyway, I'll leave it there for today. Next time I'm going to be taking that model and I'm going to be extracting the geometry so that I can do some solar analysis. So I've actually got to go to Japan now. I'm in the middle of packing. It's the night before and I haven't quite finished, and I'm just trying to finish off this video before I go. I would have liked to have shown you all the solar analytics stuff this episode, but you know, it's been very long already. It can wait till I get back. Oh yeah, we're going to Japan in the morning. And so long as Mount Fuji doesn't explode while I'm climbing it, then mata sanshu, dekimasu, arigato.